Hi, everyone. My name is Jack Kuhr, and I'm the research director at Payload. Welcome to our webinar on MBSE. We have an awesome panel today, awesome discussion. As always with these webinars, let's try to make it an open conversation with the audience. So if you have any questions real time, just plop them in the chat, and we will try to get, often we get a fair amount of questions, so we'll try to get to most of them real time. But we have a really great panel today. I want to just start off with intros. If we can just go around in a circle, maybe a 30-second intro each. Chris, do you want to kick things off? Maybe a brief intro on yourself?
Yeah. Hi, guys. I'm Chris Daywalt from True Anomaly, our senior director of programs here at True Anomaly. So I'm responsible for the delivery of our program efforts to our customers, including our internal IRADs plus our external customers. We got a series of things that we are definitely excited to be building here at True Anomaly between our Jackal spacecraft and our Mosaic spacecraft. I come from the industry, within the space industry. Spent most of my time cutting my teeth as a system engineer, mission system engineering from Orbital and Ball, and then did some consulting work also with critical government customers over my time. And that brings me to where I am here today at True Anomaly.
Great. And Clayton?
Yeah, hey everyone, Clayton Birchenough here at Agile Space Industries. Currently, I'm chief engineer on A2200, our throttleable lunar lander engine. I've been working on a bunch of models over here for performance modeling and validation throughout my time, as well as at my previous position at Aerojet Rocketdyne, where I did system modeling and performance there for the RL-10 and RS-25 engines. Yeah, and Agile Space Industries, just for those who don't know, are developing a whole suite of propulsion engines and thrusters, as well as systems.
Great. And John?
Hi, I'm John Alser. I'm head of electrical engineering at Radiant. We're designing and building a 1 megawatt nuclear reactor that's designed to be portable and can be deployed to different locations. Been with Radiant for about a year, and my entire team is responsible from everything from our internal in-house electronics design to our electrical architecture and our embedded software. Prior to Radiant, I was in the automotive EV startup industry for about 8 years, doing everything from controls development to systems engineering, and yeah.
Great, awesome. And Pari, why don't you, if you can give a broader maybe intro on yourself, the webinar, and also Flow Engineering.
Absolutely. So I'm Pari. I'm the founder and CEO of Flow Engineering. We are building a next generation systems engineering tool. So the sort of crude way to think about Flow is we're sort of a next generation requirements management tool and an MBSE tool built into one. Our sort of goal and our mission is really to help next generation space, nuclear, automotive, EV companies develop massively faster and get to market months, if not years faster. And I'm very proud to say that we're working with some of the best space, nuclear, automotive companies in the world, including Radiant. So John over here is a customer of Flow. What prompted the webinar today is really we hear MBSE be used a bunch in the industry. And like my personal experience has been that the companies that are moving the fastest and that are moving the best and are getting to market much quicker and iterating much quicker are all taking the same approach to MBSE. And it's not the approach that Boeing is taking. Most of these companies aren't even using any MBSE tool to do that. I'd say the biggest requirements tool in the world today is Excel, and the biggest MBSE tool in the world today is PowerPoint or Draw.io. But these companies are really embodying MBSE and moving faster. So what prompted the session, the webinar today, is really to help communicate and articulate from some of the best engineering leaders in the world around the table today, what the heart of MBSE is, like what's changed in systems engineering to prompt this, and what a modern startup that is moving much faster, that really cares about time to market can do to help level up systems engineering without needing the clunk of like a old school MBSE tool.
Great, awesome. So I think what would be helpful is before we jump into MBSE, let's just talk about system engineering. Maybe what is the role? Maybe Clayton, we can toss this one to you first. What is the role of system engineering at Agile, and how do you see it, and maybe how is it evolving? How do you guys approach it?
Yeah. So I'll just get started quickly with, we develop components for spacecraft primarily. So the amount of like systems complexity that we deal with is, not nearly as much as the people on the call here who are developing, nuclear power systems or a whole spacecraft subassembly. They need to integrate those components or our components into their systems and stuff like that. So the systems engineering we do is primarily, requirements, V&V, and, how components of our assemblies, our engines themselves fit together kind of. So the engine I work on is probably the most systems engineering unique product that we have, because there are a lot of the throttling engine aspect of it specifically requires, a mechanism, interesting injector components, and then everything associated with making that engine throttle. So it's all about getting those products and components of that engine to work together is primarily the systems engineering that I see occurring mostly at Agile Space Industries.
Great. And maybe, Chris, do you have anything to add on that? Maybe how has it changed? How has system engineering changed over the years?
Yeah, I think, system engineering's gone through ebb and flows over the couple of years. For a long time, system engineering became very focused on requirements and verification, validation. But the best system engineers that I've encountered, they know how to ask the right questions at the right time. They have the right breadth and depth across a myriad of disciplines to then be able to integrate a system together and poke the right engineering questions to actually get to the root of what are some of the interface issues that are going to happen between different subsystems, different parts. How are they making sure that, we go right a concept of operations, we have that ConOps that establishes what we want to do, but how are we making sure that's actually in the engineering thought every day? How is this piece part, this board, this software, this engine, what Clayton's bringing together, how is it going to get used in the system? And are we using it appropriately? And then asking the right questions and make sure its design and the integration of that design is coming together. And I think that's where we've seen the industry morph to. And that's where we're starting to see things like the new way of doing model-based system engineering come to play, is that's not, not everything is in a Cameo model. It's more, is PowerPoint, is Excel, maybe the fastest way to get to those kind of questions and bring an entire system approach.
Great. And John, maybe getting into model-based system engineering, if you can just give a definition of how you would define MBSE. I know you use Flow's tools, so clearly it's important to some degree in your organization. But can you just talk about your experience with it?
Yeah, I mean, I think to kind of Chris's point, things have kind of changed over time. Model-based system engineering, I think, originally was really kind of tool focused. It was the Cameo tools, it was your SysML tools and all of that. And that kind of had this massive amount of overhead associated with it. And as with kind of any sort of model, garbage in, garbage out, I think the real goal and approach that we've tried to take here at Radiant is to try and have a method and a process of taking, your high level product requirements, your regulatory requirements, all of those aspects, and then breaking those down into, functional architectures that can be mapped to your physical architecture and then taken through V&V. And approaching that in a way that is as lightweight as possible and is really centered around, to Chris's point, of identifying the key dependencies between your components and between your systems and making sure that things aren't falling through the cracks.
Got it. So it was in utilizing it, you're increasing communication, but somehow you mentioned that you're reducing overhead and maybe simplifying it as well.
Yeah, so I think the fact that Radiant hasn't tried to adopt some of these larger tools like SysML based that have 20 different steps to follow, and you're getting into a lot of granularity into your system. It's really about identifying the problems that you're trying to solve as a systems engineering organization. And I think the key ones are really trying to look at those dependencies between systems, make sure that you're locking them in, understanding them, and having a method and framework of understanding that if those dependencies are changing or adjusting, what the overall impact to your organization is going to be, the different engineers. So the whole goal there being lightweight as possible and not just adding process for process sake.
Yeah. So Pari, is that how you would describe it too? I mean, how would you compare what Flow's product to maybe other traditional system engineering or system engineering products, or maybe Oracle products?
Yeah, so like, to best describe that, I think you've really got to put into context what's changed in systems engineering over the last 30 years. So systems engineering maybe 30 or 50 years ago really came from regulatory engineering and like government customer engineering. It was really a quasi-legal function that exists with shall statements to like enforce and mandate certain suppliers would do certain things. And that's not the systems engineering we see today. A systems engineering team inside of a modern company like Radiant or True Anomaly or Agile is really had two things change for them as compared to those legacy government customers. The first big change is the cross-functional nature of systems engineering, right? So like 20 or 30 years ago, it was completely fine if you gave 5 systems engineers and you put them in their own little office in the corner and they could go do their work and the engineers would do their work, and at the end of the program they'd meet. But in today's level of like complexity, there is no way that works. Like your mechanical, your electrical, your software, your systems engineers all need to be very deeply coupled. So like the first big change that's happened in systems engineering is kind of like everyone is kind of needed to become a systems engineer, or at least everyone needs to be in the process of systems engineering, because we're all engineering a system, a product or a system. And the second big change that's happened is really around speed, right? If you are NASA or you are the government, it's completely fine to take 5 years on ConOps to basically flesh out and design these conceptual models where you have a really good understanding of what's going to impact what. But if you're like True Anomaly or Radiant or you're Agile, you got to get products to market really quickly. And you don't have the luxury of spending 5 years in this hypothetical universe where you get $10 million to do a trade study. You've got to get something out the door as quickly as possible. And when those two things happen together, it means you need an 80-20. Yeah, you need something that's lightweight. I think John's used the word lightweight 2 or 3 times. And you need something that's deeply cross-functional and collaborative to really embody this new way of doing systems engineering. So to answer your question earlier, like, we think systems engineering has changed, and like the SysML IBM doors world is kind of dead. Maybe the government will do it for the next 20 years, but that game's over. And the new game is really around, can my overall engineering team have a single source of truth for what the requirements are, where those requirements come from, and what we need to do and what we need to execute on today to be able to help develop our system.
Yeah. We have a question in the chat that I want to get to. This is, again, for you, Pari, but the question is, our chief engineer has made it a point that he'll only start caring about MBSE or automated system engineering when he has something like a live view of all system requirements on a web page that turn green or red at the moment an analysis or design is updated that affects their status. And the question is that something that Flow does, or is that in the product roadmap?
So give us a call. Yeah, that's what we do. So like when I say we're a requirements tool and an MBSE tool, what we basically do is we integrate these functions and these teams and these different design tools. So when a change happens in an Excel model, that drives a change in a Python heat transfer model, that then drives a change even into CAD, and that breaks one of your rollups, that entire thing is traced and is automated. So we're kind of taking the best in class of what you're seeing in the software engineering world with CI/CD, and those practices with like software in the loop and hardware in the loop testing are all coming in. But we think analysis in the loop is also really important, not just hardware and software in the loop, to be able to help teams move faster. So that's what we do. Give us a ring.
Yeah. No, that was easy. Go ahead, Clayton.
Yeah, I was just going to jump into on like one of the changes I think that's occurred with MBSE as well, and trying to deploy it to startup organizations like ourselves is I think traditionally we had more lockdown requirements and deliverables, but if you are a startup working with other startups to get something to market, some of those requirements and the agility required for the deliverable can sometimes be a little ambiguous. So being able to like change the product and change the requirements and then bring that back to the models is I think where we've seen a development as well, because MBSE really started I think in traditional large aerospace companies where the product that you need is really locked down, and so are some of the requirements at the beginning, I think more so than we have at small startup organizations.
Well, just to riff on that for a second, like I think what you're talking about, Clayton, is kind of the heart of what's changed. If you take an old school government organization, their mission is to lock down change, right? Like, and change is bad because they look at the Gantt chart and they're like, hey, we're going to add $1 billion if we start changing stuff. And I think when you look at a modern organization, like a modern space or a nuclear company, you kind of know your assumptions aren't going to be right. And like your goal isn't to be right. Your goal is to learn as quickly as possible and date those assumptions live and to give everyone a live view of those things. So like the core of systems engineering has gone from avoid change and lock down systems to kind of propagate change as quickly as it happens and as soon as it happens in that development program, so we can design and get to market faster.
Right. And we've really muddled the definition and execution steps of systems engineering, I think. And that's primarily where MBSE, I think, is going to take hold more and more, is trying to, work with the ambiguity and communicate changes effectively in organizations.
I think it very much matches up with, this is kind of verboten maybe on an engineering podcast here, but it's very much like organizational theory plus engineering organization kind of coming to bear. Like in organizations that, it's now the more modern way to do things is as a networked organization, right? Small teams that can work really fast and agile together. And that's the same thing, John. That's where you go with lightweight, is it's get to the point faster. We don't need this massive tree of requirements to be able to get to like, what's the real requirement? what's the real value that we care about? And how do we make sure that that's being communicated across the different lines that are necessary? And things like flow can help do that, because that's inherent in the immediate approach of like, no, let's get to the networked piece of this quicker so that we can actually talk about the real requirements that are driving us day to day. Do I need a requirement that says Jackal shall fly in space? No. Don't. I don't need that to be this parent requirement that trees all the way out. I think one of the challenges we're really running into, and it kind of gets to maybe the first question that's coming up here in the chat, I don't know if our primary customers, particularly in the defense space, are ready for that yet. I don't think they're fully ready to have that level of autonomy that would need that comes out of having a true networked approach to how to do this. It's just very different, and it gets into different metrics and different ways we go do this. A lot of the reasons why some of that treeing has been set up is it gets to approval levels and the way that we want to actually have interactions and an engineering review board and change control board and who has what approval over certain requirements and all that. I think the faster we can solve that, and the more that we just start getting to a place, at True Anomaly, we're very much, and I know Agile is very much in the same boat too. Let's get the product to market, and then our customers will buy a product. They're not going to buy integrated day-to-day labor of engineering for 5 years. And I think getting to that state and flipping the bit towards that is what's going to help answer things like, does it matter if it's SysML V1.6 compliant in that future? I don't think it really matters, because what they're doing is they're buying the end product.
And there's something really important about, which is, I think there's this idea in legacy aerospace, which is, hey, if I just do all 125,000 steps, we're going to guarantee a great product, And then you look at Starliner, and they did those 125,000 steps bit by bit with every single person, like overly bureaucratizing every element, and then the product didn't work. And like they sort of missed the point of The purpose of MBSE and these tools isn't to go do the work. The purpose of this is to go build a great product as quickly as you can, and then go to build the next iteration, the next iteration.
Learn as fast as possible.
Absolutely.
It used to be fail fast. I like to say learn as fast as you can. Failures and successes you can learn from, right?
Yeah, so Boeing was using MBSE, right? Pari, we were talking about that earlier. And does SpaceX use MBSE?
Well, I can't speak for either organization. Like personally, I can't go and validate. What I see is old school companies pay a lot of people to do work in these old school tools, and they don't build the right product. And new school companies don't buy any of those old school tools, and they build the right product. So like I think the core thing to go communicate is the essence of MBSE and the philosophy of MBSE is really important, but the tools aren't reflecting that. Like I'll go back to the point around the biggest requirements tool in the world is Excel, and the biggest MBSE tool in the world is PowerPoint. The best companies I see in the world that are doing the best systems engineering are quick and dirty about it. They pick a lightweight way of doing it, and they get on with it, but they have one unified model, one unified thing that everyone in the organization can, one, understand, two, collaborate on, and three, adjust as we learn. So it goes from this really like hard-baked systems architecture that requires a whole bunch of work to go do, to like, oh, we learned something, that's wrong, we're going to change the requirements. That's wrong, I'm going to take that valve system out, I'm going to replace it with valve system number 2 with these 5 requirements. The core of MBSE has always been one unified model that every stakeholder, every engineer in the organization can collaborate on. And I don't think you're seeing that reflected in SysML, and I don't think you're seeing that reflected in Cameo.
John, yeah, go ahead, John.
Kind of ripping off of that, Pari, I think, especially with those larger organizations, when you segment off systems engineering, and I think you mentioned this earlier, have them in a dark room, banging out system architectures, there's an inherent detachment from, the actual implementation that's going on. So it's really important to make sure that really everyone, I don't care if you're designing a little component over here, really takes a systems approach and really thinks about how does this component fit in the larger context of the system, and what are the problem statements that we're trying to solve by it. Because then one, that automatically gets your entire engineering organization thinking about, what are the dependencies that really are key to whatever I'm designing, and then also lead you to really try and identify those gotcha points earlier. Those things that fall through the cracks that, if you have that segmented team just kind of building an architecture, they're going to miss because they're not thinking about it day to day from an implementation standpoint.
And then just on that, like something that Chris mentioned earlier as well is the networked / integrated point here is you got to talk to a person. And this is something that people think, oh, if I just put everything in the tool will be great. No, it's about a team executing on it. And you need a person to own a system. You need a person to own a requirement. And don't worry too much about, do I have every single element of documentation around this? Have a name, have a rationale, and then if it changes, just go talk to walk over to the desk and talk to the person, and you'll learn more in 5 minutes than you will in any sort of 25 hours of going through a verbose tool.
Yeah. We have a bunch of questions that we should spend the next couple minutes going through. Here, one of them, maybe John, this can be for you because you use the tool. It's about documentation. And how is the MBSE software interacting with specific documentation?
Yeah, so it's kind of a broad question. I guess it depends on what you mean by documentation, right? Are we talking about documentation for the product yourself that you're maybe generating for like a regulatory body, or is it documentation that you're ingesting? I'm a little unclear on the question, but maybe on the former point, generating documentation from your requirements. I think it's really important to make sure that whatever you're using to track your requirements eventually ties back to the documentation that you're creating. Really, when I think about documentation, especially for something that you're presenting to like a regulatory committee or really anyone else, it's really saying, hey, here are the design criteria that we use to develop the product. Here's what the product looks like, and here's what our verification and validation for that product are. And so having a good amount of linkage from like your requirements management tool, which are really laying out that first point, and then also hopefully tying back to that latter point on your verification and validation is kind of key, right? You don't want them to be overly detached.
Yeah.
Hopefully I answered that question.
Yeah, and another question we have, and this goes back to our conversation about Boeing versus SpaceX. And the question is, and I think this is an important question that people are going to ask, so maybe Chris, I'll toss this one over to you. But the question is one criticism of MBSE is its unfulfilled promise of innovation and speed. One of the best companies in the world, SpaceX, is SpaceX, and MBSE has minor to negligible utilization. How would you sell to SpaceX and SpaceX alumni founded companies if they've had success without it? Chris, you want to take a stab at it?
I think this gets into what is MBSE to some extent and how does it get applied. So if we think about MBSE as a classical sense and like using Cameo and using just classical system engineering approaches, that is not something that SpaceX went and did. Absolutely. But SpaceX has a ton of test capability, and SpaceX has a ton of model generations capability for how they actually know how their rocket's going to perform off the launch pad. They integrate that in really quick into their failure analysis tool sets. And that's something similar that we do at True Anomaly, right? We focused upfront on developing our hardware in the loop simulation, our software in the loop simulation, so that's the focus of our model-based system engineering approach. And it's the front line of every engineering change we go make, every engineering analysis we go make. It's the front line of how we actually perform operations, and we do evaluations on a regular basis. And it's matched up with our wargaming tools that are within our Mosaic ground system. That's really where the model-based piece comes in, and that emulates very much what SpaceX has done in the past. Get straight to software in the loop type simulations, kind of skip over that step of maybe interconnected model based that you would see in a SysML or a Cameo, and like try to get in the hardware and the software as quickly as possible.
I think like an important question, like the question is like, does SpaceX use MBSE? I think the more important question probably is, what does success with MBSE look like, and does SpaceX have that thing? And success with MBSE is, does everyone in the organization have a live view of what the system is, what it needs to go do, and how we're testing that? And if they've got those things, then it's sort of irrelevant. And I'd say unequivocally, like it's been demonstrated through their success that they have those things, that you go to any engineer and they'll have the latest view. And Boeing maybe doesn't have that, like despite having invested millions into MBSE.
Point. Clayton, I have another question from the audience on how do you balance rigor with speed? Cameo takes too long, but PowerPoint, Visio lack a lot of the features that make other MBSE tools useful. Do you want to take this one?
Yeah, sure. I can speak to that real quick. I think that question is really important in the context of the complexity and the team that you're working with. If you are an early stage startup, you're trying to get a product to market, and for Radiant, for example, that product is nuclear a generator, basically, nuclear powered generator. And the amount of systems engineering required to do that is extreme. So, integrating, I think, MBSE from the core a little bit is really important from that aspect. And yeah, just really going back to the complexity, I think it really depends. Can you test it really quickly? How expansive are your requirements that you need to validate, and how fast are they changing, and what framework you're actually using to verify and make sure that the product's working. And for some people, PowerPoint and Excel work really well, but it all goes back to that complexity, I think, and the timelines that you're working with. And it can be, an overhead for an organization to kind of implement some of these tools. But, in some use cases, that overhead, and depending on what tools you're using, because that overhead could not be extreme, it can really impact what tool is actually the right choice for an organization.
Yeah. And then there's another question for you, Chris. And it's on, so we talk about different emerging trends in MBSE, which we can get into more after this question, but one of them is digital twin and wargaming. So the question is, how do different companies building MBSE like models integrate those models in a digital test range or wargaming environment? For example, how does True Anomaly take another company's model and add it to their Mosaic test range?
Yeah, that's a great question. So, wargaming is certainly a huge effort, and it's a multi-system, multi-ball approach that has to be taken into account. What is the operating picture? What's the environment that we're operating in? How many systems are we actually trying to model in there, and what are their capabilities on top of that? How much thrust do they have? What orbit are they in? What timing are they able to actually apply different constraints? What sensors are on board? And classical uses of that have been something like SDK, to do some of that level analysis. But it's extremely manual to get in there and set up Astrogator to go make that happen. And so what we're doing at True Anomaly is very similar to some things that are happening at the Virtual Warfare Center, but we're trying to take the next steps with that. And it's integrating standard model sets compliant with the unified data library so that we can form that operational picture and then do Monte Carlos constantly on what is the right flight corridors, how do we approach these different threats that might be in orbit, or different other satellites that might be in orbit that we need to avoid to make sure we're keeping the world safe, right? We're keeping ourselves safe, we're keeping other satellites safe. So that's the start. Number one, there has to be some version of standardization. So starting with the UDL for all its goodness and badness, that's a good starting point. And as we advance what those standards are, and we find out, working with groups like the National Space Defense Center out of Colorado Springs, what the right outputs of that Monte Carlo are, that's where we were going to be providing continual feedback into the UDL and like, hey, it would be nice if this is what a standard target deck actually looked like, and just iterating very quickly on that and working with them in an ingrained system. Yeah.
Great. And what are some other emerging trends? And this can be for anybody who wants this. And we talk about digital twins. How about AI integration or other emerging trends that you guys see with MBSE? Maybe Pari, you want to take this one?
Yeah, go on. Oh man, where do we start with the whole AI thing?
Yeah.
Well, I'll give you our current take on AI. And AI changes so quickly that like 3 months from now, it's probably going to be completely invalid. We think AI is going to be one of the most important technologies in the generation. Like it's already panning out that way. When it comes to systems engineering, I don't think we're doing the basics well enough. Like, if you go chat to like anyone on this call, or you survey 100 systems engineering teams, and you say, what are the 3 biggest problems you have? AI won't be one of them. And it'll be like, hey, My mechanical team doesn't know what the requirements are, and they refuse to log into this tool because it takes like 1,500 clicks to be able to get to their data. It will be like, hey, I don't really have all the test cases linked to my requirements. It's like really fundamental stuff. And when we look at, and we regularly benchmark AI at Flow, and when we look at AI, we don't think it's completely changing the game. I think in 10 years' time, it probably will. AI will probably go change everything. But we think here and now that the bigger sort of ROI element, at least for Flow and for what our customers are asking us for, is help us do the basics right and help us get a product to market and help us sort of like win the early adopter, take the market element. And that's just really around communication and collaboration. Now, once you have solved the communication and collaboration problem, once you've got every engineer in the organization on a unified requirements MBSE tool, then you can start to do really interesting things that you couldn't do before with AI, right? You can, like, if your mechanical engineers are there and your control engineers and your software engineers are there and you're tying in tests, software in the loop, hardware in the loop, analysis in the loop, you can start to use AI to identify things that might go wrong and interfaces that might break ahead of your engineers. But that only happens if you solve problem number one, which is like, can you build a real source of truth that your team can trust?
Pari, I think that's really well put. I think it comes down to how much data is actually available to do real machine learning and then match that up with actual AI. You know, in a lot of other industries, there is boatloads of customer data that has been produced over a long period of time that has then enabled that to happen. And I don't think we're at the point yet, but we're getting to the place where we're getting more trained on like standard data sets, how we're actually going to actually produce the amount of data that's necessary to then feed into successful machine learning models to then wrap AI around. But we're in the infancy of that. It's too sparse right now. And now as we really get more available, that's when it'll come to bear, and it'll take time. It'll take a little bit of time.
And like the point you touched on there, Chris, is really important because we're in an industry where customer data needs to be protected. Like, you can't go spitting your requirements from the DoD out into ChatGPT and have Microsoft looking at that. Like, that just doesn't work. So you shouldn't buy those early requirements tools that are all about AI because they're just sending it to ChatGPT over the API, and that is not safe. I think once we have the data there, we're going to need to find ways to do this in a safe and mature and responsible way. But we'll get there. I promise you we'll get there in the 5 to 10 years, but it's probably not going to be the next 2.
Yeah,
I think kind of just to quickly jump in here too, one of the problems that you're going to see is the types of systems you can apply AI to as well. You know, heavily functional safety related systems, right? The analysis that you have to do almost comes down to like formal proofs, right? And logical proofs. And when you're throwing things into a model and getting results, but it's kind of a black box and you don't necessarily have a good understanding of what that formal proof is that got you to that answer, it's really hard to use in those contexts. And not saying that that problem will eventually get fixed at some point, but it's a big challenge. And I think anytime you're dealing with something of like high functional safety, it's just a problem that is not solved right now in that space using AI for that.
Yeah. And to jump into, you know, the rolling in of AI into these tools as well, since they're not where they need to be, I don't think yet to be able to roll into our workflow entirely, like you were saying, John. It's interesting to think about the complexity of those AI algorithms and how we're going to actually then incorporate them, because the rigor then that you need to apply to get verifiable and like unique results from those models only goes up with the usefulness, apparent usefulness of those as well. So just kind of being able to roll that in and, you know, verify the results that you're getting from those models, I anticipate only is going to, you know, get orders of magnitude harder.
yeah,
It's almost a product in itself, right?
Right, exactly. And then there's, you know, the communication is already difficult between, you know, systems, and you throw in an AI model that, you know, one of the software engineers only understands or, you know, can get a few results out of. How do you incorporate that into your workflow as an engineer designing some completely different component? What's the confidence on that and uncertainty in the results there as well?
yeah. Another question we had in the chat John, maybe I'll toss this one to you, but it's on requirements, changing requirements, and it's on how do you differentiate requirements that are set in stone versus the one that are willing to be changed. The questioner asked or said it can occasionally feel like 90% of requirements are internal and can all be changed, but understanding that the permutation can be overwhelming. So not much of a specific question there, John, but just can you talk about changing requirements and how that factors into MBSE?
Yeah, no, for sure. So I think there's two key points there. One is always understanding where your requirements come from, right? One thing that we have really appreciated about Flow is being able to look at requirements in different contexts. So being able to look at them in terms of the design units of the system or component versus kind of the hierarchy, which is where the requirement was derived from, and saying, okay, is this a requirement that's coming from some regulatory requirement? Is this maybe a product requirement where there's a little bit more organizational flexibility, so on and so forth? The other aspect is you have to document rationale in your requirements. And I think this is a key thing that a lot of organizations miss, is documenting rationale. There are so many times where you will probably create a requirement that has some number in there that is really just pulled out of there for convenience. You know, it's not necessarily derived from anything in particular, but you needed a place to start from. Having that written in the rationale will let people who maybe are coming back to that requirement understand that that's really not a hard requirement. This was just something that was laid out so that we can move on and continue designing and working, versus, you know, rationale that's like, hey, this ties into this regulation here, here, and here. This is hard, we can't change. So those are, I think, the 2 points: being able to view requirements in different contexts, seeing where they're coming from, and then having that rationale behind them.
Yeah. Pari, do you want to, I don't know if you're keeping track of the questions that are plopped. Can you see them? There's a ton. But are there any interesting ones that you want to cover?
Okay, so 2 quick points. Number one, I've annoyed a bunch of SysML people. So let me go make it worse, and really dive into why I think SysML isn't good. And I think it sort of comes back to, there was an awesome question that Clayton answered around speed versus rigor, right? Like that, I think is the ultimate question for startups versus the government. Governments are all about rigor at the cost of speed, and startups, if you're not enough about rigor, you're going to blow up a nuclear reactor. That's not good for anybody. Or you're going to blow up a missile, or you're going to blow up a rocket engine. But there's probably an 80-20 in rigor. That's really, really important here. Like, let's take 2 examples. Let's take a government customer and a new space customer. A new space customer has all of their requirements in, let's say, something disgusting, like a JSON doc or a notepad document or a Word doc or something awful, right? But all their requirements are in one place and their systems architecture is in one place, or it's one of our customers is building a fusion reactor. And the way that they do this is they have a wall in the office and they have post-it notes representing systems. They write requirements on the post-it notes and then they have string connecting the systems together. So that's their MBSE tool. Their MBSE tool is the wall. And on the other side, on the government side, you've got this really verbose, powerful, sophisticated requirement MBSE tool like SysML that's really being utilized. Like SysML out of the box takes some configuration, but let's say like you do all that configuration, you integrate it in with everything, and you've got this really verbose but really powerful tool. Of those 2, which one is going to be successful? And my answer is always it's the guys with the thing on the wall. And the reason for that is when something changes, how quickly can you reflect that? And how quickly do other people in the organization find out? Like, can you reach out to that person and say, hey, like the requirement to change is A, B, and C for this reason? And can they go in a networked way, as Chris says, go start working on that change? the point I'm making here is it's typically better for a startup to start at speed and then to add rigor once you're starting to make mistakes than it is to start with a whole bunch of rigor and then try and retrofit speed into that. Like adding speed to rigor is something I've never seen work, but adding rigor to speed is something that I've seen. So we have customers coming from two different sides, right? We've got the Jira XL customers, and that's where I spend a lot of the time helping teams that are moving quickly add rigor to what they do, and that typically works great. Where another half of our customers come from is they're using some of the old school legacy tools, and they've got all the rigor, and now they're trying to work out how to do speed. And that's a much tougher cultural problem to go solve because it comes out the people and the mindset and the sort of cadence of the organization. And really what you want to do in the early days is you want to get that right. So I'd say it's better to add rigor on speed than it is to add speed on rigor. And if you're on Excel like that, but every single person in the organization knows those requirements, you're great. Like problem solved. Like you haven't got traceability, that sucks. The DoD is not going to be happy with you. Your customer's not going to be happy with you. Those are problems you can go solve with money and with traction. But the core of systems engineering is my team glued together? When a change happens, is everyone fully aligned on that change?
Just to rip on that for a second, I think kind of gets into something we've talked about earlier, where the time and place on when to implement MBSE and get to that level of rigor is really important. And getting to good requirements quickly, speed, helps the teams move forward really fast at the beginning. But to add the rigor in, I think what John was talking about there with the rationale is spot on. Right? That's the adding the rigor. And we've fooled ourselves a little bit in the industry where rigor comes from massive trees of requirements.
Yeah.
That's just volume. That's not rigor. But if we write a requirement that says the GNC mode shall be 100 hertz, and the rationale for that is because it's a decade away in frequency from the slosh mode of the vehicle and the prop system that's in there. Well, now we understand why we wrote that requirement. That's rigor, still one requirement. Not a huge volume, not a bunch of trees, but it's really easy to then have a communication path that understands, okay, I got to make sure between GNC prop and the sensors that we have on board that are going to actually measure and feed that GNC system are well communicated and connected because we did a good job documenting the rationale for why we came up with this very specific one requirement, as an example.
I like just to riff on that for a second. Sorry. I think the old school way of thinking about it is, hey, I've got this requirement, and the requirement is a design point, and that design point is the thing we're going to go hit. And that's not really what modern teams do. Modern teams start with a window, and that window is kind of moving. It's kind of dynamic, and it's kind of based on a lot of assumptions. And then over the project lifecycle, that window will, one, get smaller, and two, will get firmer as some design assumptions and design criteria turn into like things that we know with a high degree of certainty. But like that's the nature, like the modern nature of systems engineering is it's about playing in a window and it's not about hitting a design point.
Yeah, and just kind of something I think we've all been talking around but haven't directly addressed. The biggest part of all of this is building a culture around a systems mentality. I don't care how much rigor you have or how little rigor you have, if you don't have the right kind of cultural mentality of being collaborative, looking for the dependencies, providing rationale, as Chris mentioned, it's going to fall apart. I don't care if you're using a giant tool that has 20,000 steps to complete, or if you're using Excel, it'll fall apart. But really just instilling that culture, just as with any process that you bring in place, is really going to make or break whether it's successful.
Can I ask John a particular question? Just because you talked about functional safety, and what you guys do is you build nuclear reactors. So if you have a functional safety incident, that's like a really big deal. And that's not to do with like rocket engines or missiles, but like it's really, really important that you get this right. But you guys also, to me, are one of the teams that I look at where I'm like, wow, the culture's amazing and they're moving insanely fast. How do you thread that needle between like regulatory and functional safety, as well as a culture of moving quickly?
Well, I think first and foremost, you have to have everyone thinking about safety all the time. And really Radiant from the start has really been focused on safety. That's one of the key aspects of our design, something that's always driven us forward. So one, making sure everyone is aware that, they're designing something that needs to be safe. Then I think the other aspect of it is looking at whatever product you're developing and carving out the critical characteristics of the system that need to be safe, right? So there's lots of parts of a nuclear reactor that need to be designed right to be safe. And then there's quite a few parts of a nuclear reactor that are needed for it to function, but don't necessarily inherently tie into safety, right? So carving out those segments and then saying, hey, these are the pieces that we need utmost rigor on and need to check all the boxes and have a really tight process is really key. And then making sure that you're not dirting any of those parts by bringing in the less rigorous parts of your design into those functional chains, right? So that's something that I think we've done really well at Radiant is, using the regulatory frameworks to identify what those critical characteristics of our systems are that need that amount of rigor, and then making sure that we're segmenting them off so that the rest of the organization can still move at a relatively high pace without sacrificing that rigor for those important pieces.
Amazing.
Yeah, that's a good anecdote and way of tying it back to Radiant, what you guys do. I want to now take that and ask Clayton and Chris similar questions. We have around 8 minutes left, but we'll start with Clayton just on how you're building. I don't know if you're on the team, but Agile is building thrusters, lunar lander thrusters. Is that correct?
That's correct. Yes.
Yeah. So how do you? I mean, that is a very high. It will be, and that's for the Astrobotic.
The A2200 that I currently work on is going to be for iSpace US.
Okay. Well, those. It's a very high cost of failure and high attentioned mission, and very important for NASA and the CLIPS program. These thrusters, obviously, we saw, and it might be a different type of thruster for a different part of the mission, but we saw previously what happened with the first Astrobotic lander, which I don't believe was an Agile thruster on that, but just curious how, given it's a high profile mission, and these are all high profile missions, how do you look at rigor versus speed, and how do you identify the certain things that John was mentioning as well for your program?
Yeah, so I think one key element here is always the constant collaboration and communication with stakeholders. Constantly working with our customer iSpace and flowing down requirements. What do we really need to be looking at from a system perspective that the engine needs to do and perform? And so that can kind of direct the rigor in terms of where we apply that to the engine. We're all about building great products, but of course, there's, when you're building a spacecraft, there's certain system failures that you're more prone and more worried about. And so kind of identifying those key risks and, from a system level and flowing those down to the component manufacturers is absolutely critical there. And then, everything to do with the unique product design and how that incorporates to the system as well, and collaborating, not just them to us, but us back to them on, what some risks may be associated with the uniqueness of the engine, and collaborating to kind of mitigate those through test and analysis.
Great. And then Chris, I know we only have, this will be the last question. Actually, you know what? Before I ask you the last question, Chris, and it's going to be the same question about how do you work with a lot of your customers are DoD customers, and how do you manage that? We can go around quickly and just provide ways of contacting you guys, because there's a lot of follow-up questions. Do you guys all have LinkedIn's? Is that a good way to contact you guys? That seems to be the easiest way nowadays. That's actually nice. Okay, so everyone has
But
everyone,
my email is also Pari, Pari, at flowengineering.com. So drop me a message on LinkedIn or just drop me an email and I'll get around to answering it.
great. That's Perry's. And then Chris, you want to provide your email too if people have questions?
Yeah. LinkedIn or email chris.daywalt@trueanomaly.space.
And John?
Yeah, LinkedIn is probably the best, but my email is john@radiantnuclear.com.
Great. And Clayton?
Yep. Similarly here, LinkedIn or Clayton at agile.space.
Awesome. And Chris, last question of the day, just on how you manage kind of rigor versus speed with your customer, which is primarily defense applications in the DoD.
Yeah, the biggest thing with our customers is they are really seeking speed a lot now. They're starting to use that language, but what's one of the most interesting things that we're working with our customers on right now is how to actually implement that contractually. And that has proven to be probably more challenging than one would expect on a day-to-day basis. And it doesn't necessarily mean that our customers aren't trying. It's just getting that alignment across a very large enterprise takes time. And so one of the ways that we're actually trying to immediately address that and not end around the contractual space, but like do it in partnership is it gets back to, as a startup, we're actually inheriting and taking on a lot more risk in the product development cycle up front. And what we do is instead, it's taking agile ideas from software land and applying it to full development lifecycle. And it's constant collaboration and communication with our customer base, getting that user feedback, getting that into our product development cycle. And then that's helping us accelerate where we're at and where we show up with our customers with a much more mature product at the start of a program than you would traditionally see if you go down major national asset class where it's 5 years, 7 years, 10 years development cycles. That's the number one way that we're going about addressing that, but it's all reliant on that deep understanding of the user base and their needs, and then getting that into our engineering development cycle and using tools like Flow, using tools that help us do better integration and understanding, hey, when this user has a very specific need, what does that mean across our product development roadmap and our cycle, and where do we need to tweak our engineering to serve multiple customers then?
Great. Guys, this has been an awesome conversation.
Can I throw in a very quick plug?
Please.
So two quick things from me. We are currently building a white paper around the 5 levels of Agile and Iterative systems engineering, where like level 1 is basics or slightly traditional, and level 5 is fully enlightened. And it's becoming a really powerful tool to benchmark where your organization is culturally on that. So if you would like early access to that before it goes live in a couple of months, please just drop me an email or a LinkedIn. The other offer we're running is if you sign up for a demo in the next week, sort of before the start of September, we'll give you an extra week on your trial completely for free. So that's just a hot promo we've got running. But if you would like that white paper of the 5 levels of Agile and Iterative systems engineering, please just drop me a line. I'd be delighted to share that with you.
Awesome. This has been great, guys. Appreciate the time and appreciate the audience for tuning in as well. But thank you all. Take care.
Thank you all.
Take care. Bye.
Bye.
Thank you. Bye.